what can SSDs do to help transfer the enterprise systems? Some of the issues that the storage has today is the latency. HDD has very high latency. If you look at the CPU and DRAM, you'll see over time the CPU and DRAM have both improved dramatically when it comes to the performance. But the hard drive has pretty much been stagnant. Why is that? Well, an HDD cannot spin any faster. And because of that, the IOPS are pretty much stagnant growth. There's nothing they could really do. SSD, on the other hand, every single generation of SSD, the performance improves, and it improves pretty dramatically. So let's look at the power consumption as one factor. If you look at the SSD, there's no moving parts. An SSD is basically all semiconductor components. The HDD has motors, it has spinning media, basically. So because of that, if you look at the active power, you have about a 55% power savings on average between an SSD and a spinning, that's a 15K SAS hard drive. In idle, it's even better. The idle power for the SSD is greater than 75% less. So huge power savings. Now let's look at performance. Again, a 15K SAS drive, you're probably looking at that 350, 400 I/O maximum per drive. When you look at the enterprise SSD, every generation of drive gets better. From our first generation, it was about 40 times better performance than that hard drive. Now we're looking at basically 100 times better performance. The I/O performance continues to grow. So if you combine these and you start looking at IOPS per watt, you're talking about getting up to 200 times better IOPS per watt. But the numbers I'm showing you here are basically on a general 70-30 read-to-write ratio. So let's take this then, look at it in a system itself. If there was 40 users, and this was a system that had 2 SSDs versus 8 hard drives, with 40 users, you got about 2 times better performance. As the users grew, basically the gap in performance grew as well. So as you moved up to 100 users, you talked about 6 times better performance. If this was 1,000 users, that performance gap is going to even be better. At the VMworld last year, we worked closely with HP, and they helped build a system for us. So this system had 8 of our SSDs in one, 8 15K SAS drives in the other. We were running just a typical SQL server. This was showing random reads, which was a very basic development of the servers. Most of these servers are very random accessed. What this graph shows here is the IOs as the queue depth grows. So basically what we're saying is the more commands or the more users that are on these servers, the worse the hard drives performed. Beyond a queue depth of 2, the hard drive basically failed. It pretty much flatlined and couldn't keep up with the commands that were being addressed to it. This is the results using the solid-state drives. You could clearly see as there was more users coming on board or more commands going on board, it actually performed better. We were able to sustain close to 8,000 IOPS even through a queue depth of 32, and the numbers actually were the same at queue depth of 64. The more users you put on this stuff, the better they perform. There's nothing spinning. There's no seeking with the solid-state drives. Random access, which is pretty much every server you have out there today, needs this type of performance at the front end. It really helps remove that I/O bottleneck that we run into with the hard drives. So really in conclusion for the SSDs, we talk about it as instantaneous break even. On the average IOPS, it's 95 times better. The power's 55 times better. IOPS per watt over 200 times better. And the TPC testing is 6 times better at the system level. And that's really, that improves with more users. The gap just continues to grow.